Now we're going to learn something called a distance and midpoint formulas and also circles. It's not good. Distance formula, midpoint formula, and a circle. So those are the three things we're going to learn right now. Okay? Now the first one, we talk about the distance. You should know that when we talk about the distance, we always use either zero or positive number. We don't have a negative distance. We don't really say negative distance. For example, you say the distance between Washington, D.C. and New York is 250 miles. And the distance from New York to D.C. is also 250 miles. You don't say negative 250 miles. Make sense? So when we talk about the distance, we use the positive or zero part. Then on the number line, if you have this point, let's say this is a 5, this is 8. How do you find the distance between these 2 points? You use 8 minus 5, or you use 5 minus 8 and then take absolute value, right? So the distance here, distance between these 2 points is 3. Make sense? Okay, so this is on the number line. This is the one-dimensional space. What about in the two-dimensional space? If we have this x and a y axis, there's a 0, and I got 2 points. See this one, that is x1, y1, and there's another point here, x2, y2. All right, can you find the distance between these 2 points? Can you find it? Okay, so let's do this. I draw this vertical and horizontal dotted line to show that, and this gives you a right triangle, isn't it? And this is from x1, and here, of course, this x coordinate is x2, and the very similar, this is y1, and this is y2. Right, now can you find out the distance from here to here? The distance from this point to this, the little right triangle, this little point. So the distance between these two is the distance between the x1 to x2. So this distance is x1 minus x2. And then we take absolute value of that. Make sense? So that's the length or the distance between this point and this point. And very similar, the distance between the top point to this one would be the absolute value of y1 minus y2. It doesn't matter if you use y1 minus y2 or y2 minus y1. Usually we do y2 minus y1 because from 5 to 8 we use the later number minus the early number. But actually it doesn't really matter because we're going to take the absolute value. All right, now once you have the length of this side and this side, by Pythagorean theorem, if you remember, we have a, b, and the c. So that is a squared plus b squared equals c squared. This, you know that, right? Okay, so once you have this distance and this distance, you can use the Pythagorean theorem to find out the distance between these 2 points. Literally, you find the c squared, which is the distance square. Then you just need to take the square root. Therefore, the distance between x1, y1, and x2, y2 equals square root of this square. Let me just use x2 minus x1. Again, I said it doesn't matter because once you take the square, it doesn't, x1 plus y2 minus y1 squared. So this one is the distance formula. If I give you the x and y coordinates of these 2 points, and then if I ask you to find out the distance, you should be able to find it, okay? Just use the difference between their x coordinates, square it, plus the difference between their y coordinates, square that, add these two squares together, then take the square root, take the positive part, right? So you get this distance. All right, so this is distance formula. Now, let's do a quick review on the number line. Again, the one-dimensional space. This is 5, this is 8. Can you find where is the middle number or the midpoint between these 2 points? If I give you 2 points on the number line, where is what is the point or value of this one? So that would be 5 plus 8 over 2, right? So 5 plus 8 over 2, which is the average of these two. So that's 13 over 2, and which is a 6.5. So I know this is a 6.5, right? Okay, again, very similar. If you have this two-dimensional space, xy coordinate plane, and then you have x1, y1, and the other point is x2, y2. And we just learned how to calculate the distance between these 2 points. What about if I ask you to find the midpoint of this little segment? What is the xy coordinate of this? Then the midpoint. Again, you can do this just like what I did earlier. Did you see that the x coordinate of this midpoint is right in the middle between x1 and x2? And the y coordinate of this midpoint is here. It's right in the middle of y1 and y2. Therefore, the midpoint xy coordinate will be x1 plus x2 over 2, comma. This is the x coordinate, and y1 plus y2 over 2. So the average of the x, average of the y, that's the coordinates of your midpoint. Okay, so this is the midpoint formula. Okay, it's not really difficult. Just use, let's just use one example to show that. Give you 2 points, okay? x1, y1, that is -1 and 4. Okay, the other point, x2, y2, I give you the coordinate is 3, 2. I ask you both. Can you find the distance between them? Can you find the coordinates of the midpoint? Okay, the distance equals square root of x2 minus x1 square plus y2 minus y1 square, right? That's the distance. So x2 is 3. There'll be 3 minus -1 square plus 2 minus 4 square. Okay? And the next one will be easy because the 3 minus -1, which is a 3 plus 1, so that's a 4. And a 4 square is a 16. And 2 minus 4 is -2 square, that is a 4. So you get a 16 plus 4, that is the square root of 20. And there is a complete square as a factor of 20, 4 by 5. And take the 4 out to get a 2. And inside you have a 5. So this is the distance between these 2 points. And the midpoint will be -1 and 3, right? You take the average of these two. So -1 plus 3 over 2, and then 4 plus 2 over 2. See, that's the average between these two x coordinates and the average of these two y coordinates. And that equals 2. -1 plus 3 is +2 over 2 is 1. 4 plus 2 is a 6 over 2 is a 3. There we go. So I get the midpoint. That's my answer. And also I get the distance. That's my answer. Okay. And I want to show you exactly where are they. So the first one is -1, 4. This is y. There's the x. And the 0. And this much is 1. Okay. So -1, 1, 2, 3, 4, which is here. And the other one is a 3, 2. So 1, 2, 3, and the 2 is about here. All right. So the distance, I'm sorry, I have to draw it like this one. And this is the distance. Did you see that? Here is a 2, here is a 4, right? So 2 squared plus 4 squared, 16, plus 4, which is 20, and that's the square root of this 20. That's the distance. And the midpoint is right here. See, 1, 3. That's what we got earlier. Okay, if you like it, of course, you can graph it to verify your answer, but you don't really need to. The formula itself is very good enough. Okay. All right, so try one more without drawing, okay? I just give you, can you find the distance and the midpoint? The distance between these 2 points. 1, -6, -8, -4. Distance. Distance will be, if you like, you can put a little mark here, x1, y1, okay, and x2, y2, because when you plug into the formula, it might be a little helpful because you come here to say, oh, that's x2 and this is x1. But once you do a couple of exercises, you don't really need to. Square root of this minus this, so -8 minus 1 square plus -4 minus -6 square. -8, -1, that's 9, right? Yeah, and then 9 squared is 81. So I have an 81, and here is -4 plus 6, which is 4. Which is 2. 2 squared is 4. So that answer is root 85. That's the distance. You find it. That's the distance, and the midpoint. Midpoint is the average of the x, so 1 and -8 over 2, -6 plus -4 over 2, right? Average means you add up divided by 2. So that is 1 minus 8, which is -7. So that should be -7 over 2. And then -6 plus -4, which is -10 over 2, which is -5. Therefore, you get the distance and you get the midpoint formula. Okay, so we done. So far, we finished 2/3 of the job. Circle. Before we do circle, I want you to know, let's see, this is x, this is y, and here's a 0, and here is r. Here's a center, and we call this is hk. This is the hk, that's the coordinates of the center point. And remember, when you draw a circle, the circle has this property. That means every point on the circle, the distance between every single point on the circle and the center is the same, and that is r. R is the radius. I'm sorry, this is not very pretty, but okay, so that gives you the idea. Therefore, if I ask you to draw try to do it better. If I ask you to draw a circle, okay, for any, I need the equation of the circle. So for any point on the circle, I call that xy. And what's the relationship between this xy and the hk? And this is r. The radius is r. The distance between every single point xy to the center, that would be, look, that would be x minus h squared, right? X minus h squared plus y minus k squared. The distance is r. So that gives you the general form or format or general equation for every single point on the circle. Every single point on the circle xy must satisfy this. Okay, we take square both sides. So if you ever see an equation looks like this, that is a circle. So x minus h squared plus y minus k squared equals r squared. Every single time when you see this type of equation, you should know that it's a circle. Now, if I give you hk, which is the coordinates of the center, and I also give you r, can you give me the equation or the standard form? For example, if I give you h and k is 0, 0, that's the center, which means your circle has a center at the origin point. and then that has the radius. If I give you the radius, it's a 3. Can you give me the equation? HK is 0, 0, so you just substitute a 0 here, and put in 3 here. So you should have x squared plus y squared equals 9. Because here is x minus 0 squared, x minus 0, just x squared, and here is minus 0. You don't really need to write it, so that's y squared, and here is r squared. So be very, very careful. We have this form, x squared plus y squared equals 9. The radius is the square root of it, okay? It's not 9. It should be the square root of 3. See? It's not bad, right? What about next one? If I ask you to write me the equation that has the center at 2, negative 3, and if you like, you can put a little h, little k here, so you can remember, oh, that's h, that's k. And also the radius is 4. Can you do that? Okay, so that will be x minus h, so x minus 2 square plus y minus k. Here, k is negative, so y minus negative 3. And later, I'm going to change that to be y plus 3 and equals r squared, right? So, and I know r is a 4. So I have x minus 2 squared plus y plus 3 squared equals 16. So if I give you an equation look like this, first of all, you say, oh, that's a circle. And where's the center? Remember here, x minus k. You have to take the opposite sign of the number after this x. So the center should be 2, negative 3. So don't just say negative 2, 3, okay? It has to be opposite sign. So the center should be 2, negative 3. And what is the radius? Radius should be the square root of this number, so which is a 4. Okay? Sounds good? Next question, or the next thing. We have to review a little bit about how to complete the square. Let me give you a quick. I think you learned this earlier, but I'm not 100% sure. So if you have x squared minus 6x, first of all, you look at this coefficient of x squared term, that is 1. All right, now we're going to do it. Next one, the coefficient of the x term is negative 3. Okay, remember half square. So I say half square. Those are the two magic words, which means half of this number, half of that number, half of negative 6 is negative 3, right? And the square of negative 3 is 9, isn't it? So what you need to do is, when you complete square, you do this. X squared minus 6x plus 9 minus 9. Where is this 9 coming from? You half of this coefficient, square it. Half of that is negative 3, square it is 9. So that's why you plus 9 minus 9. The good thing is this is a complete square, and that equals x minus 3, whatever the half is, square, and then keep writing the negative 1. So x squared minus 6x. You look at every single step I'm doing. I'm not changing the value. That's why I can write equal, because I plus 9 minus 9. Therefore, this is the same as that one. And then from here to here, I just combine the first 3 terms. I rewrite that into this form, minus 9. So the whole step here, half and then square, will help you to complete a square. Okay? So let's try another one. If I give you a expression x squared minus 6 minus 18, can you complete square? Yes. Again, half, negative 3, square, 9. Therefore, you do this. X squared minus 6x, you plus 9 minus 9. Every time you plus and minus the same number, you're not changing the value. And then you copy this 18. You have to bring this negative 18 with you to make sure that you can write equal here, okay? And then this is a complete square. It's x minus the 3 square. And then you just need to combine the letter 2 forms, the letter 2 parts, so that's negative 27. So you're completing square, okay? Try one more. Y, I changed that. So y squared plus 4y. Can you complete square? Remember, half it, square it. So I get y squared plus 4y. First of all, the square term has the coefficient 1, so I'm okay to use the method half and then square. So half of that is 2. Square of 2 is a 4. Therefore, I'm going to plus 4 minus 4. Every time you put plus 4 here, you just write a minus 4 immediately. So make sure that you're not changing the value. And the first 3 term right now is y plus 2 square minus 4. So you are completing square. Why we need to do this? Okay, why we need to do this? Because let's see this example we had earlier. X minus 2 square plus y. Let me just copy that. X minus 2 square plus y plus 3 square equals 16. Okay, so this is a square. We know that when we see this form, we know that that's a square centered at 2, negative 3 with a radius of 4. So once you have the center, you know the radius, you can draw the circle. So this is the circle. What about if I expand this? If I expand this, I open this, I use either FOIL method, I use the formula, I get an x squared minus 4x plus 4 plus y squared plus 6y plus 9 equals 16, okay? Then I get x squared minus 4x. Those are numbers, so I'm going to combine them. I just copy everything about a 6, x and a y. And then here's a 4 and a 9, which is the 13. If I minus a 16 on both sides, I get a minus 3 equals 0. What about this one? This is also a circle. This is exactly the same or equivalent to this one. If I give you this type of equation, can you find the center? Can you find the radius? You have to rewrite this back into this standard form. Then you can find the center, you can find the radius, isn't it? So from here to here, see, you have to complete a square. Okay, from here to here, you have to complete a square. That is why we do this quick review, and then we do that. And then let me give you one example to see how we do that. If I give you a equation looks like this: x squared plus y squared minus 6x plus 4y minus 12 equals 0. All right. This, I tell you, this is a circle. Can you find the center and the radius for me? Okay, you got to complete square, right? So you're going to combine the x squared minus 6x, and then you're going to combine y squared plus 4y, and then we can leave the number at the end. Okay, let's do, we complete a square of this guy. So that will be x squared minus 6x. Remember, here coefficient is 1, so we're safe. We're okay to do the half then square. So half of that is negative 3. Square it is 9. So I do plus 9 minus 9. Okay? And then I do y squared plus 4y. Again, the coefficient of the square term is 1. So I do half it, square it. Half of that is a 2. Square that is 4. So I plus 4 minus 4 immediately. And then I minus 12 equals 0. This is a complete square. All right? So that is x. Half of that is negative 3 square plus here y plus 2 square. That's good. And then we look at the numbers. Here is a negative 9, negative 4, that's a negative 13, negative 12, so I get a negative 25 equals 0, right? Okay, so then I get x minus 3 square plus y plus 2 square equals 25. Are you ready? Are you ready to give me the center? Center will be opposite sign of that, 3, negative 2. That's the center. And what about the radius? square root of this guy. Okay, don't forget to take the square root. 5. Okay, so this is the standard form of the circle, and will help you very easily to identify the center and the radius. Now from here, it's not that obvious all the way to here. So that's why I give you the quick review how to complete a square. I hope you remember that. Okay, so after today's section, you know how to find the distance between 2 points in the xy coordinate plane, and you can find the coordinate of the midpoint of the segment of 2 points. And then also we learned the equation of the circle. We learned the standard form like this, and to identify the center and the radius. So that's a lot, but it's not very hard. I hope you like it.